Hi, my name is Yani, and in today's video, we are going to talk about the basic arithmetic logic gates, we will cover the half adder, half subtractor, full adder, and full subtractor circuits. Half adder circuits are combinational logic circuit that is used to add two one-bit digits. Half subtractor are the opposites of half adder. Instead of adding two one-bit digits, it is being subtracted. In the following clips, we will see how these two circuits are being constructed and how this circuit works. In this circuit, we are going to create the half adder circuit. As we can see, there are 6 components already in place, which are the two LEDs, which are the green one represents the sum, and the red one which represents the carry, and its corresponding resistors with the value of 220 ohms. The ICs used are the 7486 or the exclusive OR gate IC, and the 7408, which is the AND gate IC. And these LEDs are already connected to the ground. These wires will correspond to its output wire. So first, we are going to input our output wire, connect the output wire into the output of the 7486 for the green LED, and for the red LED to the output of the AND gate, which is the 7408 in pin 3. Now, for creating our input, first we are going to connect our input wires, which represents these green wires here. But before we going to connect the other pins, we should power first our IC. So the pin 14 will connect to the 5 volts. The same goes with the AND gate, and then pin 7 to the ground for both ICs. So there. Okay. Now, we are going to connect its corresponding inputs. So first, these two inputs will be connected to the first pin of the IC on 7486, and the other one to the pin 2 of the 7486. Then the other two will be connected to the AND gate. We're connecting here to the first pin, and then the other one, which is here. Here. Now we're going to power our IC. Over there, wait. Yeah. So as we can see, the red LED already light up. So which represents the carry. So if both of the input is connected to the ground, which is represent the 0, 0, both LED turned off or both of them are in the state of 0. When the second input is connected to 5 volts, the green LED, which represents the sum, lit up. The same goes when the first input is connected to 5 volts and the second input is connected to the ground, which represents also that the sum is in the state of 1 while the carry is in the off state or in 0 state. When both of them is connected to the 5 volts, as we can see, the green LED turned off while the red LED turned on, which represents the carry, which means that if both inputs are in the state of 1, the carry will be in the state of 1 also, but the sum is in the state of 0. In this circuit, we are going to make the half subtractor circuit. As we can see, it is the same components used, but with the additional one, which is the 7404 NOT gate IC. As we can see, the LEDs are already connected to the ground, and we shorted the breadboard since the other half of the breadboard is not connected to each other on its power line. So first, we are going to power our ICs by connecting its pin 7 and pin 14 to the ground and VCC respectively. So VCC here. There. And next is the ground pin, which is in pin 7 here. It's not seen in the camera, so this is the pin 7 of this 7408. There. Here. And there. Here. Yeah. Now it's already powered up. Let's connect its circuitry. So first, our output will be connected to its output pin. For the green LED, we connect it to the output pin of the 7486, which is the pin 3. The same goes for the red LED, which is in the pin 3, 1, 2, 3, and the AND gate. In this time, the green LED represents the difference, while the red LED represents the borrow. So first, we're going to set up the inputs. The green wire represents input X, and the white wire represents input Y. Here. And then, first, we connect input X to the first pin of the 7486 or the XOR gate, and then pin Y is to the second pin of the XOR gate. There. Next is on the pin of input X, connect it to the first pin or the input pin of the NOT gate, and the output of the NOT gate is connected to the first pin of the AND gate, which is here. There. Next is we're going to connect the second pin from input Y to the second pin of the AND gate. Here is the circuit, and then we try to power it up. There. So since here the circuit, so now we can demonstrate the circuit. So first, if both of them, if inputs X and Y are connected to the ground, the LED both turn off. The difference and the borrow is in the low state or zero state. When input Y is connected to 5 volts, both of the LED light up, which means that the difference in the borrow are in the state of 1. But when input X is connected to 5 volts and input Y is connected to the ground, both of the the green LED light up, which represents the difference, while the borrow turned off, which means that the borrow is in the state of 0 and the difference is in the state of 1. When both of them are connected to 5 volts, both LED turned off, which means that the difference in the borrow is in the low state or in the state of 0.
As we see on the construction part, half adder and half subtractor are almost identical, but half subtractor uses NOT gate on one of its input. As we see on the truth table on this side, carry is only on when 2 inputs are on, while on half subtractor, both difference and borrow are on when the input B is on. For our next circuits, we will construct a full adder circuit and a full subtractor circuit.
In this circuit, we are going to build the full adder circuit. We have modified some of the ICs. Now we have new IC, which is the 7432 IC or the OR gate IC. But we still have the AND gate IC and the exclusive OR IC. So as like the other 2 circuits, we should power it on first. The LEDs are already connected to the ground, so we should power our ICs first. Pin 14 on the VCC and pin 7 to the ground. So there, here, and here. So it is already powered on by connecting those pins in the power line. So we are going to construct the circuit with its input. So here are the input wires. The green, which represents the X, the white, which represents the Y, and orange, which represents the Z. So here are the 3 inputs used. And then to connect the circuit, first we're going to connect input X to the first pin of the XOR gate, and input X is also connected to the AND gate of the first pin of the AND connected to the first pin of the AND gate. Now, to connect in Y, to connect the input Y, we should also connect it to the second input of the XOR gate and also to the second input of the AND gate, which is the first AND gate here. And now for the input Z is connected to the first input of the second XOR gate, which is in pin 4, and to the second AND gate, and to the first input of the second AND gate, which is here. And now, as we can see, there is no connection to the output of disconnected gates. So to the output pin of the first XOR gate, this is connected to the second input of the AND gate. And this is also connected to the second input of the second XOR gate. There. So, those are connected, and then the output of the first AND gate is connected to the first input of the OR gate. And then the second input of the AND gate is connected to the second input of the OR gate. Now, to connect our output, the sum is connected, or the green LED is connected to the second, or to the output of the second XOR gate, and the carry is connected to the output of the OR gate. Now, to test, we should power it on. There. So, you can see the LED light up. So, if all of them, if input X, Y, and Z is connected to the ground, the state of the LED are turned off, which means they are on in zeros state. When input Z is connected to 1 or to the 5 volts, the LED of the sum will turn on. When the input Y is connected to the 5 volts or in the on state, the sum will be turned on, which represents by the green LED. When input Y and Z is connected to 5 volts, the carry will be in the state of 1, which is represented by the red LED. When input X is connected to 5 volts, the sum LED will turn on. When X and Z is connected to 5 volts, the LED will turn on, which represents the carry or the red LED. While if X and Y is connected to the 5 volts, the carry will be in the on state. When all of them are connected to 5 volts, both of the LED turn on. In this circuit, we are going to create a full subtractor circuit. As we can see, the LEDs are already grounded, and there are the 2 hanging wires that represent the output wires for the corresponding LEDs. And now we have a new IC that is being added, which is the 7404 NOT gate IC. So first, we should power our ICs first, or connect it to the power line. So, as earlier, pin 14 is in the VCC. For each IC, so pin 14 here, and here. Now, we should connect the pin 7 to the ground. So, for this type of circuit, this is pin 7. Almost these ICs have almost the same pin out, since they have the same in the same series. I use a blue wire since I am running out of wire. So there. Now we connected. Now the ICs are already connected to the power. So let's connect the inputs, which we'll be going to use for our full subtractor circuit. So the green represents X, white is for the Y. Let's adjust. So green for X, white for Y, and Z for orange. So we are going to use 3 inputs for this circuit. So now, for the circuit 3, for X, we should connect it to the first XOR gate on its first input of the XOR gate. The same goes with Y. So here, So, X and Y are connected to the inputs of the XOR gate. Now, X also is connected to the NOT gate. So, we connect X to the first, so the input of the first NOT gate, and the output of that NOT gate is connected to the first input of the AND gate. And then the Y input, let's use the orange wire. Y input is connected to the second input of the AND gate, of the first AND gate. There. So now, for the output of the XOR gate, of the first XOR gate in here, pin 3, is connected to the first input of the second XOR gate. So it seems that we short the pin 3 and the pin 4. And it is also that the pin 3 is also connected to the NOT gate. So we use the second NOT gate and connect it to the second AND gate here. Now, we will try to connect Z. So Z is connected to the second input of the, let's use a shorter one. So Z is connected to the second input of the second XOR gate. There. And then here, Z is also connected to the second input of the second AND gate. There. So, the output for the second XOR gate is the LED that represents the difference, which is the green one. And the output for the AND gates are connected to the inputs of the OR gate. Here, this is the first one and the second one. There. And after that, the LED that represents the barrow is connected to the output of the OR gate. So this is the complete circuit. So let's see. Since my camera is off earlier, so this is the full subtractor circuit. We will demonstrate how does it work. So if X, Y, and Z is connected to the ground, both of the LED turned off, or the difference and the barrow is in the state of 0. When Z is connected to 5 volts, both of the LED turns on, it means that the difference and the barrow is in the state of 1. When Y is the only input that is in the high state, both of the LEDs are also light up or in the state of 1. When Y and Z is connected to 5 volts, the LED that represents the barrow will be in the high state. So, when X is connected to 5 volts, the LED that represents the difference will light up, while X and Z is connected to 5 volts. Both of LEDs are on the off state, while X and Y is connected to 5 volts. Both of the LED are in the off state. When all of them, X, Y, and Z, is connected to 5 volts, both of the LEDs turned on.
As we see, this circuit requires 3 inputs. They consider the carry and the barrow from the previous results. The circuit is similar to each other. However, the full subtractor uses NOT gate like the previous circuits we built, which is the half subtractor. The truth table, which is shown here, is somewhat similar when these two are when the bits are being added or subtracted manually. If you like this video, and see you again next time.